LlamaIndex is one of the most popular applications or frameworks out there when it comes to generative AI. LlamaIndex is primarily a data framework for large language models based applications. LLMs like GPT-4 or even Llama-based models, they come pre-trained on massive public data sets. But if you want to train them on your own data set, then you would need some data framework like LlamaIndex. So LlamaIndex, in other words, provides a query interface that accepts any input prompt over your data and then returns a knowledge argument response. LlamaIndex has recently launched their latest version, which is called as LlamaIndex point 9. This is one of the most innovative release so far from LlamaIndex, and one of my coolest features in this release is called as transformation caching. Transformation caching is really cool. The problem what it is trying to solve is that building production retrieval augmented generation requires a lot of parameter tuning to get right. And these parameters could be input data, chunk sizes, embedding, metadata extractors, and much more. So how do you efficiently experiment with data ingestion without needing to recompute the entire pipeline? So how can you deal with incremental data updates, or how could you try out different downstream extractors without needing to recompute the whole chunking or your pipeline? That is where this transformation caching helps out. LlamaIndex has created a production-ready abstraction which is called as ingestion pipeline, which standardizes the transformation steps required in the RAG pipeline. So all you need to do is to first define the data source, second define the series of transformation functions they want to perform, and then define the downstream sync. If you look at this code chunk which they have provided, this is what they are doing. First import the modules, then create the pipeline, which is the abstraction as I mentioned earlier, and then just run the pipeline fully, save it, and then just start some caching there, and then you can do the incremental checking. And then because you are using caching, so the performance will be very quick. Now, if you want to define a cache, for example, maybe in Redis, you can do that too. And I'm more than sure there will be more and more in-memory caches available for this Llama index. So fairly cool. I'll drop the link to this in video's description so that if you want to play around, you could. For me, I think this really stands out. If you are already using it or plan to use it, please share your thoughts in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.